Hello there and welcome to the calm space of LUMIVERSE NL, a place where science rests between dreams. Tonight, we drift quietly into the heart of astronomy, the oldest story ever written in light. It begins with a single spark, a photon born in the core of a distant star, traveling billions of years just to reach your eyes. Every shimmer in the sky is not just a point of light, but a message from the past, crossing oceans of time to whisper, "You belong to the universe." Astronomy is the study of everything above us and within us, from the calm glow of our sun to the invisible dance of galaxies far beyond. It teaches us patience. The universe moves slowly, in rhythms too vast for a single lifetime. Galaxies swirl, stars are born, planets form, dissolve, and form again. Every second, something new appears in the dark, a reminder that the cosmos never sleeps, it only breathes. Look up. You're seeing what was, not what is. When light leaves a star, it carries a memory, one that takes centuries, even millennia, to arrive. To gaze at the night sky is to look into time itself, to witness the story of creation written across an endless page of darkness. And though our planet feels small, astronomy reminds us, smallness is not insignificance. It's connection, an invitation to rest inside something far greater than our thoughts. So tonight, don't try to understand every detail. Just let your breathing slow. Let your shoulders loosen. Imagine yourself drifting between constellations, weightless and calm. The day can fall quietly behind you. The universe, infinite and patient, unfolds ahead. You are part of it, not apart from it. Every breath you take began in the heart of stars. Every moment of silence is the echo of ancient light. So let us begin this journey together. One fact, one wonder, one heartbeat at a time. If you enjoy these gentle voyages through science and sleep, consider subscribing or leaving a quiet thought below. It helps others find their way here, one sleepy soul at a time. Explore the universe within. The cosmos is listening. 1. The universe is not still. It breathes, stretches, and expands, faster than we ever imagined. When astronomers first looked into the deep sky, they expected to find galaxies slowing down, tugged gently by gravity's invisible hand. But what they found instead changed everything. Galaxies are racing away, not slowing, accelerating. As if pushed by a mysterious force hidden within the fabric of space itself. They called it dark energy, a quiet power that fills the cosmos, unseen yet stronger than all the stars combined. It does not glow or move. It simply pushes, expanding every corner of reality farther and farther apart. This discovery reshaped astronomy forever. In 2011, it earned the Nobel Prize, not because it solved the mystery, but because it deepened it. Imagine this: space isn't just growing, it's accelerating. The galaxies we see are drifting away faster with every passing second. And one day, if this expansion continues, even light itself will no longer reach us. Scientists call this the Big Rip, the universe's possible final breath. First, galaxies would drift apart. Then solar systems would separate, torn from their stars. Eventually, the force would grow so strong that even atoms, the very fabric of matter, would be pulled apart. Everything, from stars to space itself, dissolving into silence. But this vision is not a prophecy of fear. It's a reflection of scale, of how vast and fragile the cosmic order truly is. Dark energy reminds us that even emptiness is not empty. It hums with power, quiet and relentless, shaping the future of everything. Astronomy is not just about what we can see, but what we can feel through evidence. Invisible truths that still touch every part of existence. Dark energy may never be captured in a telescope, yet its presence defines our fate. Every moment, the night sky becomes a little wider. Every second, space itself stretches, making room for new mysteries to unfold. So tonight, as you close your eyes, imagine the universe expanding gently around you, galaxies drifting like lanterns on an infinite sea. You are part of that motion, carried silently by the same cosmic tide. The stars are not leaving you, they are taking you with them into tomorrow's greater unknown. If this calm journey brings you peace, share it with another dreamer. Let more souls drift through the stars with us. The cosmos is growing, and so are we. Time, the silent fabric of everything. For most of our lives, we think of it as constant. But the deeper we look into the universe, the more fragile that idea becomes. Einstein's theory of relativity revealed a truth so strange, it still feels poetic. Gravity bends time itself. Near massive objects like black holes, space and time twist together. To us, time may feel steady. But near the edge of a black hole, the event horizon, it begins to slow. An astronaut approaching that boundary would feel nothing unusual, yet to an outside observer, their motion would appear to freeze, trapped forever at the edge of darkness. One moment experienced up close could equal centuries far away. This is not illusion. It is physics. The immense gravity of a black hole stretches both space and time like taffy. Light escaping from this region becomes redder, weaker, as though struggling to climb out of a bottomless pit. To look near a black hole is to see time itself pulled thin. And beyond that horizon, time ceases to exist in any way we can understand. But black holes are not only destroyers, they are keepers of cosmic rhythm, the ultimate clocks of gravity. Matter spiraling around them glows with furious beauty before vanishing. Every pulse, every flicker of radiation is a heartbeat of the universe recorded in light. Even silence becomes information, a trace of what once was. Some scientists wonder, if gravity can slow time, could it also shape reality? Could every massive object, every planet, star, even our own bodies, slightly warp the flow of time around us? The answer is yes. Right now, time passes a little slower at your feet than at your head, simply because your feet are closer to Earth's center of gravity. The effect is tiny, but real. Relativity means that time is not universal. There is no single now that covers everything. Each of us lives within our own small curve of time, our own gentle distortion of the cosmic fabric. And together, these countless threads weave the story of existence. So as you rest, imagine time as something soft, a vast ocean you float upon. You are not racing through it, you are carried by it. And every heartbeat, every thought, is a small ripple moving outward into eternity. If these cosmic reflections calm your thoughts tonight, leave a quiet word below, a sign that you too drift within this great rhythm of time. Silence carries the sound of stars. 1. There are waves that ripple through reality itself, silent, invisible, and powerful enough to move galaxies. They are called gravitational waves, and they are not sounds in air, but movements in the very fabric of space and time. When two massive objects, such as black holes or neutron stars, spiral together and collide, they send out vibrations that travel across the cosmos. For billions of years, these ripples pass through everything: Earth, your body, the air around you, and we never knew. Then, in 2015, humanity heard the universe for the first time. At two quiet observatories in the United States, a pair of long tunnels filled with lasers detected a distortion smaller than a fraction of a proton's width. Space itself had stretched and squeezed. It was the echo of two black holes merging over 1 billion light years away. The signal was unimaginably small, but its meaning was enormous. It confirmed what Einstein had predicted a century earlier. Gravity can ripple. The universe can speak. Gravitational waves do not shine like light. They do not flicker or fade. They travel unhindered through stars, dust, and time, carrying a record of events that no telescope could ever see. Each wave tells a story of violence and beauty, the death of stars, the birth of black holes, the trembling of space-time itself. To detect one is to listen to the universe's heartbeat. Since that first detection, scientists have heard dozens more. Some come from colliding neutron stars, dense remnants of once massive suns. When they meet, they shake the universe with a flash across the spectrum. These collisions forge elements like gold and platinum, spreading them across the galaxies. Every ring on your finger, every golden leaf in art, may trace its origin to the crash of two dead stars. Think about that. Every human-made treasure, every piece of metal gleaming under sunlight, began as the debris of cosmic catastrophe. The next time you hold something made of gold, remember, you are holding the ashes of a star. Astronomy does not just study distant worlds. It studies the echoes that built our own. Listening to the universe has become a new kind of sight. We no longer see the cosmos only through light. We feel it through movement. Each ripple that passes through Earth carries information from unimaginable distances and times. Some began their journey before the first human ever looked up at the night sky. Some are still on their way from galaxies we have yet to discover. The cosmos is not silent. It hums softly, endlessly, in a spectrum of gravity too deep for ears but perfect for imagination. And perhaps that is the most beautiful thing about these waves, that they remind us how small changes can carry infinite meaning. A fraction of a proton's width, and yet an entire universe revealed. If this story resonates with you, let it linger. Let your next breath follow the rhythm of a distant wave. Somewhere out there, another pair of stars is colliding, and its ripple will one day pass through you. Silence, after all, is never truly silent. 1. Some lights in the universe burn with such power that they can outshine everything else. Not for eternity, but for a few extraordinary seconds. They are called gamma-ray bursts, and they are among the brightest and most violent events ever recorded. In the time it takes you to blink, a single burst can release more energy than all the stars in an entire galaxy combined. To witness one, even from billions of light years away, is to see the universe at its most extreme. These bursts are thought to come from the deaths of massive stars or the collision of neutron stars. When the core of a dying giant collapses, its energy funnels into narrow beams that shoot through space at nearly the speed of light. If one of those beams happens to point toward Earth, even from halfway across the cosmos, we can detect it. That's how powerful they are. The flash of a single event, traveling across unimaginable distances, whispering the story of destruction and rebirth. For astronomers, gamma-ray bursts are like cosmic lighthouses. Each one reveals something new about the physics of creation. The way matter transforms under impossible pressure. The way energy twists through magnetic fields. In their fleeting brightness, they hold secrets of how stars die and how black holes are born. When a burst fades, it leaves behind a silence so vast that telescopes can only trace the afterglow. The cooling embers of what was once the most intense fire in the universe. But gamma-ray bursts are not alone in their brilliance. Some stars, called hypergiants, shine with the light of 1 trillion suns. They are giants among giants, immense, volatile, and short-lived. Their radiance fills entire regions of space, shaping the gas and dust around them into glowing clouds that will one day give birth to new generations of stars. Hypergiants live fast and die young. While our sun will live for billions of years, these titans burn through their fuel in just a few million, ending in spectacular explosions that scatter elements, gold, iron, oxygen, across the cosmos. Without their violent deaths, there would be no life. Every molecule in your body, the iron in your blood, the oxygen in your lungs, was forged in the heart of a star that died long before Earth existed. It's strange, isn't it? That destruction on a cosmic scale could create the ingredients for breath, for thought, for love. The universe builds through endings. Every explosion is both a farewell and a beginning. When you look up at the night sky, some of the stars you see may already be gone. Their light continues to travel long after their death, crossing millions of years to reach your eyes. You are seeing ghosts of ancient suns, memories of energy that once burned bright and vanished into dust. And yet, that light remains beautiful. Even as it fades, it carries warmth, a message that says, everything that dies becomes part of something greater. Astronomy, in its quiet way, teaches acceptance. Stars do not resist their own endings. They transform. And maybe as we listen to their stories, we learn something about ourselves. That endings are not loss, but change. That every collapse can lead to light. So as you drift deeper into this journey, imagine the flicker of a distant explosion somewhere in the dark. A gamma ray burst blooming for an instant, then gone. Its light has already passed us by, yet its echo lives on in every atom, every cell, every breath you take tonight. If this moment of wonder has reached you, let it rest in your thoughts. Share this quiet light with someone who might need it, because sometimes the brightest fires are born from silence. 1. Our home galaxy, the Milky Way, drifts quietly through the void, but it is not alone. Far beyond the faint edges of our spiral arms, another great city of stars is moving toward us. The Andromeda galaxy, a glowing swirl roughly the same size as ours, is racing closer every second at more than 200 kilometers per second. 4 billion years from now, the two galaxies will meet in a slow, magnificent collision, a cosmic dance that will reshape the night sky forever. To call it a collision might sound violent, but space is mostly empty. When the Milky Way and Andromeda finally intertwine, their stars will almost never touch. Instead, their gravity will pull and twist, bending spiral arms into luminous ribbons. Gas clouds will crash and compress, igniting bursts of star formation. Billions of new suns lighting up the darkness. It will be chaos, yes, but also creation on the grandest scale imaginable. If any distant descendants of humanity are still here to witness it, they will see a sky ablaze with light, two galaxies stretching across the heavens, merging into a single glowing arc. Over the course of millions of years, this dance will form a new galaxy, often called Milkomeda, a blend of both names, a single vast home forged from two. And eventually, the chaos will calm. The stars will settle into graceful orbits, the gas will thin, and the new galaxy will shine quietly for trillions of years. This is not science fiction. It is destiny written into motion, a slow choreography, guided by gravity's invisible hand. Right now, Andromeda is already visible to the naked eye from Earth's northern hemisphere, a faint smudge of light in the dark. That blur is the future, reaching back at us from 2.5 million light years away. Every photon that touches your eyes tonight began its journey long before humans existed, carrying with it a glimpse of what lies ahead. Astronomy reminds us that even galaxies, immense beyond comprehension, are part of cycles. They are born, they evolve, they collide, and they merge, just like everything else in the universe. Nothing in the cosmos stands still. Even the stars we trust as fixed points in the sky are in motion, each one orbiting the galactic center at unimaginable speeds. To us, the constellations look eternal, but in reality, they are fleeting. Temporary arrangements in a vast celestial river that never stops flowing. Perhaps that's why looking up feels so peaceful. It's not the stillness we're seeing, but the slow unfolding of movement too vast to perceive. Galaxies collide, stars are born, planets form, and yet, from our small world, it all appears serene. The night sky is a slow-motion miracle, a reminder that beauty does not need haste. In time, even the Milky Way's familiar shape will be gone. The delicate arms that cradle our solar system will stretch and twist until they vanish into the larger whole. The name Milky Way will become a memory, replaced by a new galaxy we will never know. One built from the quiet merging of two ancient spirals. And yet, the atoms that make up you and me will still belong to it. The merger may erase the map of our sky, but it cannot erase our connection to it. Every galaxy is a story written in gravity, and like all stories, it continues, changing shape, but never ending. So, as you close your eyes, imagine the stars above slowly drifting, their paths crossing and weaving together in silence. The Milky Way and Andromeda are already dancing, their future sealed in motion, their rhythm older than time. If this vision of the distant future calms your thoughts, hold on to it, because even when galaxies collide, the universe never truly breaks. It simply finds new ways to shine. The stars are still dancing. 1. In the endless quiet of the universe, there exist objects so dense, so compact, that a single teaspoon of their material would outweigh mountains. They are called neutron stars, the collapsed hearts of massive suns that once burned brilliantly before dying in spectacular explosions. When such a star reaches the end of its life, gravity wins. Its core implodes, forcing protons and electrons to merge into neutrons, squeezing the mass of an entire star into a sphere barely 20 kilometers wide. It is one of the strangest and most extreme states of matter in existence. Neutron stars are cosmic paradoxes, unimaginably heavy, yet small enough to fit within a city. Their gravity is so intense that if you stood on their surface, you would weigh billions of times more than you do on Earth. Their magnetic fields are so powerful they can tear atoms apart. Yet, despite their ferocity, they are among the most precise natural clocks in the universe. Some neutron stars spin hundreds of times per second, flashing beams of radiation into space like celestial lighthouses. We call these pulsars. Each rotation sends a perfectly timed pulse of energy that can travel across entire galaxies. Astronomers on Earth detect these flashes as rhythmic beats, regular, unwavering, as if the universe itself were keeping time. In fact, the timing of pulsars is so precise that they rival atomic clocks, drifting by less than a second over millions of years. It is through these steady signals that scientists measure the shape of space-time, even detecting tiny ripples caused by gravitational waves passing between us and them. Imagine that, listening to the universe through the heartbeat of dying stars. Each pulse is a reminder that even in death, a star continues to communicate. Its light may fade, but its rhythm endures. Long after the explosion that birthed it has vanished into silence, the pulsar continues to whisper across the cosmos, a message of persistence, of continuity, of cosmic memory. There are stranger versions still. Some neutron stars evolve into magnetars, their magnetic fields a trillion times stronger than Earth's. If one were as close as the moon, it could wipe the magnetic strips from every credit card on the planet. When these titans shift or crack, their magnetic fields snap, releasing bursts of radiation that briefly outshine entire galaxies. Such events are rare, but when they happen, they are felt across the universe. Tremors of invisible force rippling through the fabric of reality. To understand neutron stars is to look at the universe's most extreme laboratory, a place where gravity, density, and energy meet in impossible balance. Inside them, matter behaves in ways we cannot reproduce on Earth. Theorists believe their cores may contain quark matter, a sea of subatomic particles so compressed that the familiar rules of physics begin to dissolve. They represent nature at its limit, the frontier between what exists and what can only be imagined. And yet, amid all this extremity, there is grace. These stellar remnants, born in destruction, serve as anchors of precision and rhythm. They are reminders that even chaos can give birth to order, that from death comes harmony. The pulse of a neutron star is not random noise. It is a cosmic metronome, guiding us through the silence. Next time you look up at the night sky, remember that hidden among the stars are these unseen drummers, spinning endlessly, beating time for the universe. You will not see their light, but if you listen, if you slow your thoughts enough, you might feel the rhythm they keep, because somewhere, far beyond sight, a star that once burned bright is still ticking, still keeping time for eternity. If this quiet pulse of the cosmos resonates with you, let it remind you that even endings can sing. Every beat in the dark is proof that silence too can have rhythm. The universe is still keeping time. 1. Far beyond the calm glow of our Milky Way lie objects so radiant they can outshine entire galaxies. They are called quasars, the cosmic beacons of the early universe, burning brighter than 1 trillion suns. At their centers are supermassive black holes, devouring matter with insatiable hunger. As gas and dust spiral inward, they form an accretion disk, a vast whirlpool of energy heated to unimaginable temperatures. Before that material vanishes beyond the event horizon, it releases light so powerful it can be seen across billions of light years. To witness a quasar is to look back in time. Most of the quasars we see today formed when the universe was still young, less than 1 billion years old. Their light has traveled for eons, crossing expanding space just to reach our telescopes. Every flicker is a fossil of creation, an ancient signal from the era when galaxies were still forming. And though they shine like eternal torches, most quasars have long since faded, their black holes now quiet, resting at the hearts of mature galaxies. Even our own Milky Way hides one, Sagittarius A. Silent for now, but once it may have roared with the brilliance of a quasar. The physics of a quasar defies imagination. Matter plunging toward a black hole moves at nearly the speed of light, compressed and superheated until it emits blinding radiation across the electromagnetic spectrum, from radio waves to X-rays. Some quasars also launch enormous jets of plasma from their poles, shooting streams of charged particles millions of light years into the dark. These cosmic jets carve through intergalactic space, sculpting their surroundings and influencing how galaxies evolve. In this way, black holes, often symbols of darkness, become engines of creation. They regulate the birth of stars by blasting away gas, preventing galaxies from growing too quickly. They are both destroyers and caretakers, maintaining the cosmic balance between chaos and order. Imagine standing on a planet near such a source. The sky would never be dark. The light from the accretion disk would drench everything in blinding blue-white fire. The air, if there were any, would shimmer from the radiation. Even the atoms in your body would begin to disintegrate under the energy pouring through space. Yet from the safety of Earth, these distant beacons are mesmerizing, silent testimonies to the universe's wildest possibilities. Quasars also serve as time markers, mileposts that help astronomers measure how the universe expands. By studying their light, scientists can trace the chemical composition of intergalactic gas and the growth of galaxies over billions of years. Each quasar, in essence, is a cosmic archive holding data from the dawn of time. Their light carries fingerprints of the first atoms, the first stars, and the earliest movements of the universe itself. But there is a deeper beauty to them, one beyond numbers or equations. To gaze at a quasar is to see a paradox made visible. A black hole, something that lets no light escape, surrounded by a blaze so bright it illuminates the cosmos. It's as if the universe is reminding us that darkness and light are never truly separate. One defines the other. The void births the glow. The ancient astronomers never imagined such things could exist. Even Einstein doubted that black holes were real. Yet today we can detect their hum, see their shadows, and witness their energy shaping galaxies, thousands of light years wide. And as our instruments grow sharper, we're beginning to find the faint whispers of even earlier quasars, flickers from a time when the first black holes were born. Perhaps one day, we will know how such titanic forces emerged from the quiet beginning of the Big Bang. But for now, it is enough to know that they exist, silent, distant, and breathtaking. They burn not to destroy, but to reveal. And in their light, we find a reflection of our own desire to understand the unknown. If this vision of light born from darkness moved you, let it linger. Share it, so others may see how even the universe's deepest shadows can shine. Every black hole carries a hidden sunrise. When we look at the night sky, we imagine we are seeing everything that exists. The stars, the planets, the soft ribbons of galaxies that stretch into infinity. But what we see is only a fraction of the truth. Most of the universe is invisible. It does not shine, it does not reflect, and it does not emit light of any kind. Astronomers call this hidden substance dark matter. And it may account for nearly 85% of all the matter in existence. The story of dark matter began not with discovery, but with confusion. In the 1970s, astronomer Vera Rubin studied how fast stars orbited the centers of galaxies. According to Newton's laws, stars farther from the center should move more slowly, just as the outer planets in our solar system orbit the sun more lazily than the inner ones. But Rubin found something astonishing. The stars at the edges of galaxies were moving just as fast as those near the center. The galaxies should have flown apart. Something unseen had to be holding them together. That invisible glue became known as dark matter, an unseen halo surrounding every galaxy, shaping its gravity and structure. We cannot see it, yet its pull is undeniable. It bends light from distant galaxies through a phenomenon called gravitational lensing, magnifying objects billions of light years away. It holds galaxy clusters together like scaffolding, forming the vast cosmic web that stretches across the observable universe. Without dark matter, galaxies would scatter like sparks in the wind, unable to form or survive. So what is it made of? That remains one of the greatest mysteries in science. It could be composed of exotic particles that barely interact with normal matter, things called WIMPs, short for weakly interacting massive particles. Others suspect it might be axions, tiny quantum particles that drift like ghosts through every atom. Some even suggest that dark matter could be made of primordial black holes, relics of the universe's earliest moments. Too small and dim to detect directly. Every possibility opens a new doorway into physics, yet none has been proven. And so, scientists search in silence. Deep underground, detectors filled with liquid xenon wait in the dark, hoping to catch even a single collision between a dark matter particle and an atomic nucleus. So far, the results are whispers. Maybe signals, maybe noise. Still, the search continues. Every passing second, trillions of dark matter particles may be flowing through your body, through this planet, through everything, unseen, unfelt, but real. To think that the very foundation of the universe is invisible is both humbling and poetic. It means that everything we know, all the galaxies, stars, and planets, makes up less than 5% of reality. The rest is shadow, structure, and silence. It's as though we're staring at a painting illuminated by a single candle, unaware of the vast canvas that lies beyond the glow. Yet dark matter isn't the enemy of light. It's the framework that allows light to exist at all. It gathers galaxies into clusters, draws filaments through space, and gives the universe its architecture. Without it, there would be no night sky to admire, no constellations to name, no gravity strong enough to bind the stars into spirals of brilliance. In its quiet way, dark matter is the unseen artist of creation, painting the universe not with color, but with form. Astronomy has always been a dialogue between what we can see and what we can't. Every discovery reminds us that the cosmos hides more than it reveals. And yet, that hiddenness is not absence. It is mystery. Dark matter may never shine, but it gives the stars their stage. So as you drift tonight, imagine yourself surrounded not by emptiness, but by an invisible ocean of presence. The dark structure of the cosmos embracing you, unseen yet infinite. Everything you know floats within it. Galaxies, worlds, and you. You are part of that hidden fabric, woven into the dark matter of the universe itself. If this vision of the unseen moves you, share it quietly, as light does when it meets the dark, because even the invisible shapes everything we love. The stars exist because the darkness holds them. To look into space is to look into the past. Every star, every faint galaxy, every whisper of light that reaches your eyes tonight has been traveling across time itself. When you gaze upward, you are not seeing the universe as it is. You are seeing it as it was. The farther you look, the older the light becomes. The moon shows us what happened just over a second ago. The sun, 8 minutes in the past. The nearest star, over 4 years gone. And the most distant galaxies. Their light began its journey billions of years before the Earth even formed. This is one of the quiet truths of astronomy, that telescopes are not just tools for sight, but for time travel. They let us witness the universe as it unfolded through its ages, frozen in the light that has taken so long to arrive. Each photon that enters a telescope lens is a memory, a messenger from a time when the cosmos was young. When astronomers look at distant galaxies, they are literally peering into history, into a time when stars were first being born, when elements were just beginning to form, when light itself was still learning to move freely. At the edge of what we can see lies a faint glow, the oldest light in existence, called the cosmic microwave background. It's the afterglow of the Big Bang, a relic from when the universe was only 380,000 years old. Back then, everything was a hot, dense fog of energy. As the universe expanded and cooled, matter began to form, and that blinding heat stretched into longer, gentler wavelengths. Microwaves that still fill the cosmos today. It's a faint hum of creation, invisible to our eyes but detectable by radio telescopes all around the world. When that ancient radiation was first discovered in 1965, scientists thought it might be a mistake. Noise from their instruments, or even from nesting pigeons in the antenna. But soon, they realized they had stumbled upon something extraordinary, the first direct evidence of the universe's birth. For the first time, humanity could hear the echo of creation itself, a cosmic whisper still resonating through the void. The cosmic microwave background is more than just light. It's a map of the early universe. Tiny fluctuations in its temperature, differences of only a few millionths of a degree, reveal how matter began to clump together under gravity, forming the seeds of galaxies and stars. Those subtle ripples are the universe's first fingerprints, a blueprint of everything that would come after. In that ancient glow, we can trace the story of our own existence, from hydrogen to galaxies, from galaxies to planets, from planets to life. Think of it this way: the light that touches your eyes tonight began its journey long before humans, long before Earth, long before the sun itself existed. You are witnessing messages billions of years old, sent from places that may no longer even exist. Some of the stars you see tonight have already burned out, their light still on its way, crossing time to meet you now. The night sky is a collection of ghosts, memories of what once was, still shimmering with gentle persistence. And yet, there's something profoundly comforting in that. It means that nothing is ever truly lost. Every light, once born, continues to travel. Every act of creation leaves a trace that endures beyond its moment. The universe remembers, not in words but in photons, in faint whispers of warmth, in the glow that fills all space. So when you look at the stars, remember that you are not looking into emptiness. You are looking into memory, into history, into the long, patient unfolding of everything that has ever been. If this thought fills you with calm, let it rest behind your eyelids tonight, because every time you close your eyes, the light still travels across the universe, across time, across you. Every photon is a memory of creation. 1. Among all the theories that astronomy dares to dream, few are as haunting or as beautiful as the idea of wormholes, tunnels through space and time, shortcuts across the universe. They are not proven, not yet seen, but they live within the mathematics of Einstein's equations, whispering that such paths could exist. In theory, a wormhole could connect two distant points in space, allowing a traveler to step into one end and emerge instantly in another galaxy, or even another time. It sounds like science fiction, and for now, it is. But the physics behind it is astonishingly real. According to general relativity, massive objects warp space and time. If that curvature becomes extreme enough, it can create not just a pit, like a black hole, but also a bridge. Two openings, connected by a tunnel so curved that distance itself folds. It would be the universe's way of bending its own geometry, forming a cosmic passageway through the impossible. Some scientists call these bridges Einstein-Rosen tunnels, after the two men who first proposed them in 1935. They realized that a black hole could, in theory, be linked to a mirror image, a white hole where matter and energy flow outward instead of in. The connection between them would be a wormhole, an opening from which something might emerge as quickly as it disappeared elsewhere. If stable, such a path could allow information, or even objects, to travel faster than light. But there's a catch: stability. Every calculation so far suggests that natural wormholes would collapse instantly, closing before anything could pass through. To keep one open, you would need something truly exotic: matter, with negative energy, an impossible-sounding substance that would counteract gravity's pull. Some physicists speculate that such energy might exist in quantum fluctuations, tiny, momentary distortions that blink in and out of existence in the vacuum of space. If they could somehow be gathered or amplified, they might hold a wormhole open long enough for light, or a traveler, to cross. But for now, this remains pure theory, a whisper from the edges of imagination. Still, the math does not forbid it, and that fact alone keeps the dream alive. Every generation of scientists has looked at the impossible and asked, why not? Black holes were once only theory too. So were gravitational waves, and the expansion of the universe. Reality often begins as mathematics, then waits for technology to catch up. If wormholes do exist, they could explain some of the universe's greatest mysteries. Why distant regions of space seem connected in strange ways, or why quantum particles can affect one another instantly, no matter how far apart they are. Some even imagine that the universe itself might be threaded with tiny wormholes, flickering at microscopic scales, quantum bridges that constantly form and collapse. Unseen but vital to the fabric of space-time. And then there are the dreamers, those who see wormholes not just as equations, but as symbols. Symbols of hope, of connection, of the possibility that distances, physical or emotional, are never truly infinite. That perhaps, somewhere beyond the veil of known physics, there are paths linking every corner of existence, every heart, every star. The idea of a wormhole reminds us of something deeply human, our longing to cross impossible distances. We build bridges, we send probes, we listen for signals from the dark, all because we refuse to accept isolation. Even in the vastness of the cosmos, we search for connection. And maybe that desire itself is the closest thing we have to a wormhole, a force that bends distance into meaning. Whether or not these tunnels ever prove real, they have already opened a passageway of their own, between science and imagination, between what is and what could be. They remind us that the universe might be stranger, softer, and more compassionate than we think. So as you rest tonight, imagine it, a quiet bridge of light arcing across infinity, linking one side of reality to another. Perhaps it leads not to another galaxy, but to a deeper part of yourself, a place where wonder never collapses and where every question still shines. If the thought of hidden pathways comforts you, let it drift with you into sleep, because maybe the first wormhole we'll ever travel through begins within the mind, a connection between curiosity and the unknown. There are bridges in the dark, we just haven't crossed them yet. In the vast silence between stars, two remnants of dead suns can find each other, spiraling closer and closer until the universe itself begins to tremble. These are neutron stars, the ultra-dense cores left behind after supernova explosions. Each one packs more mass than our sun into a sphere the size of a city. And when two of them collide, something extraordinary happens. For millions of years, they orbit in quiet isolation, losing energy as they circle each other. Every revolution sends faint gravitational waves rippling through the cosmos, distortions of space-time that stretch and squeeze reality itself. Slowly, inevitably, their dance tightens until gravity pulls them into a final embrace. When that moment comes, the collision releases more energy in an instant than all the stars in the galaxy combined. In 2017, astronomers detected such an event for the first time, both through gravitational waves and light. For the first time in history, humanity not only heard the universe's vibration, but also saw it. The collision was recorded as a brilliant flash called a kilonova, brighter than an entire galaxy for a few short days. In that flash, something almost miraculous occurred: the creation of heavy elements: gold, platinum, silver, uranium. The building blocks of our jewelry, our electronics, and even parts of our bodies were born in the heart of that explosion. Every piece of gold that has ever existed, every ring, every coin, every speck buried in the earth, once flowed as molten light from the crash of two dying stars. It's almost impossible to imagine. The atoms that form the symbols of love and wealth were once debris from cosmic catastrophe. Each fragment carries the signature of violence and rebirth, a story of stars that destroyed themselves so that matter could begin anew. That is the strange poetry of astronomy. Out of the universe's most violent events comes beauty, order, and even life. Destruction is not the end. It's the transformation that allows everything else to exist. The elements forged in those stellar collisions drifted through space for billions of years, eventually joining clouds of gas that would one day form new stars, new planets, and new beings capable of remembering where they came from. When two neutron stars meet, the universe trembles. Across billions of light years, space itself quivers as these dense remnants spiral inward, locked in a fatal dance that ends in unimaginable power. Each star, no larger than a city, yet heavier than our sun, spins hundreds of times per second. Their gravity bends light, their magnetism distorts reality, and as they draw close, the very fabric of space-time begins to sing. In 2017, astronomers detected such an event for the first time: a kilonova, the collision of two neutron stars. For a few moments, it shone brighter than an entire galaxy. It was not just light that reached us, but also gravitational waves, faint ripples in the universe itself, traveling at the speed of light. By detecting both, scientists confirmed something extraordinary: that gravity and light, space and time, are not separate, but intertwined melodies of the same cosmic song. Inside that explosion, new matter was forged, heavy elements like gold and platinum scattered into the galaxy. Every ring on your finger, every trace of precious metal on Earth, was born in the collision of dying stars. You carry within you the memory of cosmic violence, beauty forged from destruction. These moments reveal how creation and chaos coexist in perfect balance. A single cosmic event can both end and begin worlds. As the light fades, what remains are new atoms, new planets, and perhaps new chances for life to form. Every element in your body once passed through such a crucible. Hydrogen from the Big Bang, carbon from red giants, iron from supernovae, gold from neutron star collisions. You are, quite literally, a map of the universe's most powerful transformations. But among all these celestial events, few are as extreme as magnetars, neutron stars with magnetic fields so intense they could tear atoms apart. A magnetar's field is 1 trillion times stronger than Earth's. If one were half the distance to the moon, it could erase every credit card on the planet. Its magnetic grip is so absolute that it warps the structure of matter itself, stretching atoms into thin filaments. Occasionally, magnetars unleash bursts of energy, flashes of X-rays or gamma rays that can briefly outshine entire galaxies. When these starquakes occur, they send vibrations across the cosmos, silent to our ears but recorded by satellites orbiting Earth. Each eruption is a reminder that the universe is alive, restless, unpredictable, and yet governed by laws that never fail. Even in their destruction, these remnants follow a precise pattern, one that repeats through eternity: expansion, collapse, rebirth. To study such objects is to peer into extremes of physics: density beyond comprehension, gravity that bends time, magnetism that defies reason. And yet, these extremes are not foreign. They are part of the same system that gave birth to you. Every neuron firing in your brain, every pulse of your heart, follows the same mathematical laws that shape the life and death of stars. From quantum fields to galaxies, existence moves by the same rhythm. Astronomers often describe neutron stars as laboratories of the impossible, places where matter exists in forms we cannot recreate on Earth. Inside them, nuclei collapse so tightly that protons and electrons merge into neutrons, creating a sea of degenerate matter. A teaspoon of it would weigh billions of tons. And yet, within that density lies order. The laws of physics hold steady, even at the threshold of reality. It is humbling to realize that nature does not waste even its most violent acts. Every collapse leads to creation. Every death fuels another dawn. If neutron stars and magnetars are the universe's extremes, they are also its teachers, showing us that stability and chaos are not opposites, but companions. One cannot exist without the other. So as you drift deeper into calm, imagine that silent collision echoing through time. A pulse of energy crossing galaxies, arriving here as a faint ripple that your body can almost feel. In that ripple lies history, chemistry, and memory. The story of everything that was and will be. You are made of that same light, that same gravity, that same rhythm. Every breath you take is an echo of cosmic expansion. Every heartbeat is a reminder that the universe still moves within you. And perhaps, when you sleep tonight, your dreams will hum in resonance with the distant collision. A quiet song of stars collapsing and beginning again. Because rest, too, is a kind of rebirth. A return to balance, where energy finds stillness, and silence becomes light once more. The universe is full of paradoxes, places where logic bends and time trembles. Among the strangest of them are black holes, regions where gravity becomes so strong that not even light can escape. To fall into one is to fall out of the universe itself. And yet, from these abysses of darkness comes some of the brightest lights in existence. A black hole is born when a massive star dies. After burning through its fuel, gravity takes over, crushing the core inward with unstoppable force. The atoms collapse, then the nuclei, then even the particles themselves, until all mass is compressed into a point of infinite density, a singularity. Around it forms the event horizon, the ultimate boundary. Anything that crosses it, matter, light, even time, is lost forever from our visible universe. But black holes are not the simple monsters we once imagined. They are also engines of creation. At the centers of galaxies, supermassive black holes consume stars, gas, and dust. And in doing so, they release staggering amounts of energy. As material spirals inward, it heats to billions of degrees, forming disks of radiation so intense they can outshine the rest of the galaxy. These are the hearts of active galactic nuclei, the cosmic furnaces that shape the growth and fate of galaxies. And sometimes from their poles, black holes launch jets of energy, streams of charged particles traveling near the speed of light. These jets can stretch for millions of light years, sculpting the surrounding space and shutting down star formation for ages to come. It's strange to think that something defined by darkness could also be the source of so much illumination. But that is the nature of the universe. It hides creation inside destruction and light inside shadow. The first image of a black hole was captured in 2019, a blurry orange ring encircling a dark core. It was not just a photograph. It was proof that the theories were true, that the invisible had been made visible. The light we saw came from matter heated to the edge of annihilation, orbiting the event horizon just before vanishing into forever. Each photon in that image was a survivor, escaping at the last possible instant from the pull of infinity. Einstein's equations predicted black holes long before we believed they could exist. Even he doubted that nature would permit such extremes. Yet there they are, billions of them scattered across space. Some small as cities, some billions of times the mass of our sun. Some dormant, quietly waiting. Others roaring with energy, devouring entire stars. We once feared them. Now we see them as essential to the cosmic balance. Without black holes, galaxies would lack the gravitational centers that hold them together. They are both destroyers and architects. Inside a rotating black hole, space-time itself is twisted, dragged around by the spin in a process known as frame dragging. Here, time does not move forward in a straight line, but swirls like a whirlpool. In theory, one could orbit the black hole's edge for what feels like minutes, while centuries pass elsewhere. Every second near its horizon stretches into eternity. In these regions, the familiar rules of reality break down, not because they fail, but because they expand beyond our ability to imagine. And still, there is one more mystery. Hawking radiation. Physicist Stephen Hawking proposed that black holes are not completely black. Through quantum processes near the event horizon, they slowly lose energy, glowing faintly and evaporating over incomprehensible spans of time. Even the darkest objects in the cosmos, it turns out, cannot last forever. Given enough time, far longer than the age of the universe itself, even black holes will fade away into light. The lesson they offer is simple and profound. Nothing is eternal, not even darkness. The universe, vast and ancient, moves through cycles of birth and decay, gravity and release. And within those cycles, everything transforms, even the things that seem absolute. So as you drift deeper into stillness, imagine that edge, the glowing ring of matter swirling toward a horizon beyond which time dissolves. You don't need to understand it, you only need to feel it. The calm at the boundary between everything and nothing. Because in the universe, as in life, endings and beginnings are the same line viewed from different sides. If this vision of the infinite stirs something quiet inside you, hold it. Share it like a spark, not to illuminate everything, but to remind others that even darkness radiates truth. In the silence beyond the stars, the universe still burns. 1. The early universe glowed like fire, not with stars or galaxies, but with light itself, thick, searing, and alive. In those first few 100,000 years after the Big Bang, the cosmos was a dense ocean of particles, so hot that atoms could not even exist. Photons bounced endlessly off free electrons, trapped in a blinding haze. Space itself shimmered, glowing orange-white like the surface of a newborn star. Then, as the universe expanded, it cooled. Protons captured electrons and formed the first atoms. For the first time, light could travel freely through space. The glow faded, stretching into longer wavelengths as it spread outward, becoming red, then invisible. That ancient radiance still surrounds us today. The faint cosmic microwave background, the afterglow of creation. It is the whisper of the primordial fire stretched by nearly 14 billion years of expansion into a chill of just 2.7 degrees above absolute zero. When we detect it with radio telescopes, it appears as a soft, uniform field of microwaves filling the entire sky, but it's not perfectly smooth. Tiny variations in its temperature, only millionths of a degree, reveal the earliest seeds of structure in the universe. Where the glow was slightly denser, matter began to clump, and those clumps became galaxies, stars, and planets. Without those minute ripples, there would be no cosmic architecture, no Earth, no life. The entire complexity of existence began as faint fluctuations in that ancient light. The universe has always been restless. Even in its infancy, it was changing, expanding faster and faster, driven by forces we still struggle to understand. Physicists call one of these forces dark energy, an invisible pressure embedded in the fabric of space itself. It is what pushes galaxies apart, what stretches the cosmos more with every passing moment. The discovery of dark energy shocked the scientific world. Instead of slowing down under gravity's pull, the expansion of the universe is accelerating. It's as though space is not just expanding, it's learning how to expand. If dark energy remains constant, the universe will continue to grow colder and emptier. Galaxies will drift beyond one another's reach until only darkness remains. But if it grows stronger, it could lead to something even more dramatic, a fate called the Big Rip. In that scenario, expansion would one day overpower all forces of attraction. First, galaxies would tear apart, then stars, then planets, then atoms themselves. Even the bonds holding space and time together would unravel. It's an apocalyptic vision, billions of years away, but it reminds us of a profound truth. Even the universe is mortal, and yet the story doesn't end there. Some cosmologists believe that even in its eventual silence, the universe may still give birth to something new. That as space decays, quantum fluctuations could trigger another burst of creation, another Big Bang, another universe. In this view, reality is a cycle, an infinite blooming of cosmos after cosmos, each born from the ashes of the last. Every ending contains the seed of beginning. When you think of it that way, our place in time becomes extraordinary. We exist at a moment when the universe is still bright, still full of stars, still rich with galaxies whose light can reach us. We live in the luminous era, a fleeting window when existence is visible, and consciousness can wonder at its own origins. We are quite literally beings made of light, living in the light, and destined one day to return to it. So when you close your eyes tonight, remember, The darkness around you is not absence. It is the same space that once blazed with orange fire, now cooled, now calm, but still filled with the memory of light. The silence of the cosmos is not empty. It is full of ancient echoes, still traveling, still unfolding. And perhaps, within that silence, something waits. The next spark, the next dawn, the next beginning. If this reflection brings peace to your mind, let it settle there like starlight. Because even in the coldest reaches of time, the universe still remembers warmth. Light never truly disappears. It only changes form. Some stars live quiet lives, burning gently for billions of years. Others live fast and die in fire. And then there are those that defy every expectation. The stars that explode not once, but twice. These rare giants are called pulsational pair instability stars. They are so massive that the physics inside their cores begins to break down. When the temperature rises high enough, light itself, normally a steady pressure holding the star up, transforms into particles of matter and antimatter. The balance collapses. The star shrinks violently, then rebounds in a partial explosion, hurling layers of gas into space. But it doesn't die. It gathers itself again, burning even hotter than before, until the process repeats. Each pulse shakes the heavens, a heartbeat of a dying giant. Only when its core can no longer resist gravity does the final supernova come, obliterating everything in a flash brighter than a galaxy. What remains after such a death is not destruction, but renewal. The debris it casts out becomes part of the interstellar medium, a vast ocean of dust and gas where new stars are born. In this way, one star's end becomes another's beginning. The elements forged in that fury, iron, gold, oxygen, carbon, drift through space, waiting to gather again into new worlds. Every tree, every ocean, every living cell carries the ashes of long-dead suns. You are breathing stardust right now, remnants of explosions that shook the galaxy millions of years before Earth existed. And beyond these fiery deaths, the universe holds even stranger mysteries. Some galaxies, faint and ethereal, are so diffuse they are barely there at all. Astronomers call them ultra-diffuse galaxies. Ghostly collections of stars spread so thin that they seem to dissolve into the background of space. They can be as large as the Milky Way, yet contain only a fraction of its stars. Seen through a telescope, they look like smudges of light, half-formed thoughts drifting in the dark. How do such fragile galaxies survive? Some appear to be held together almost entirely by dark matter, invisible scaffolding binding their stars. Others seem to have little dark matter at all, defying our understanding of cosmic structure. They are puzzles, whispers from the margins of creation. Perhaps they are remnants of galactic collisions, the stripped cores of once mighty spirals. Or perhaps they are failed galaxies, never dense enough to ignite the bright fireworks of star formation. To study them is to be reminded that not all beauty blazes. Some of it hides in the faint, the fragile, the nearly invisible. The universe paints with every shade, from the brilliant glow of supernovae to the delicate ghosts that barely touch the edge of perception. Even the dimmest smudge of light can carry a story billions of years old. In this way, astronomy teaches patience. The cosmos doesn't rush. It reveals itself slowly, gently, across eons. The faintest glow may take centuries to reach us, and yet it arrives, precise, unhurried, eternal. Every photon that touches our instruments is a survivor of chaos, a traveler from a time before time. Think of that when you next stand beneath the night sky. Somewhere out there, a star may be preparing to explode for the second time. Somewhere else, a ghost galaxy drifts quietly. Its stars spread so thin they will never touch. And in between them lies you, a being made of the same elements, connected by the same forces. illuminated by the same ancient light. Every time you breathe, you participate in that grand cycle. Every heartbeat mirrors the rhythm of the universe itself. Expansion, collapse, renewal. Life, after all, is just another form of cosmic recycling. So as you listen to this quiet story of fire and shadow, let your mind drift with the dust between the stars. You are part of that story, born from collapse, moving through transformation, destined for return. Even when you sleep, the atoms that once burned in ancient stars are still dancing within you, remembering the heat of their first light. If this realization brings calm, hold it close, because knowing that you are made of starlight means you were never separate from the universe. You were always its reflection. The stars die, but their light keeps becoming you. 1. Every galaxy, every star, every breath you take is built on a quiet mystery, a substance that cannot be seen or touched, but without which nothing could exist. It is called dark energy, and it may be the single most powerful force in the universe. In the late 1990s, astronomers studying distant supernovae made a discovery that changed everything. They expected the universe's expansion to be slowing down. After all, gravity should be pulling everything inward. Instead, they found that galaxies were flying apart faster and faster. Something invisible was pushing them, stretching the very fabric of space itself. That invisible force became known as dark energy, and it now appears to make up nearly 70% of the cosmos. We still don't know what it is. It might be a property of space itself, a kind of vacuum energy that grows stronger as space expands. It might be a new field, woven through reality, or something even stranger, an echo of universes beyond our own. Whatever its nature, dark energy is rewriting our understanding of fate. If it continues to accelerate expansion, the universe could end not in fire, but in silence. A big freeze, where every galaxy drifts beyond sight, every star burns out, and even atoms fall apart. Imagine that future. A universe with no light, no warmth, no sound, only endless night expanding forever. It sounds desolate, but there's beauty in it too. It reminds us that everything we see is temporary, that existence itself is a momentary spark between two infinities. The cosmos was once a furnace of light, and it will someday fade to stillness. But in between, now, there is awareness, and that awareness belongs to you. Dark energy doesn't just drive the expansion of space, it stretches time as well. As galaxies move apart, light from their stars is redshifted, its wavelengths elongated like the breath of the universe slowing down. When you look at a distant galaxy through a telescope, you are not just seeing something far away, you are seeing something moving away, its very light stretched thin by the momentum of existence. Space itself is expanding between you and everything else. Even the room around you, imperceptibly, grows larger every instant, carried by the same silent tide. And yet, in the midst of that vast separation, gravity continues to weave islands of order. Galaxies cluster together, stars form from gas, planets orbit their suns, and life, fragile, improbable life, emerges to wonder at it all. It's as if the universe refuses to be uniform. Wherever there is expansion, there is also connection. Wherever there is distance, there is gravity pulling back, saying softly, "Not yet." Some scientists believe dark energy may not be constant at all. It might change over time, weaken, strengthen, or even reverse. If it reverses, expansion could slow and collapse, leading to a big crunch where all matter falls back together in one final blaze. Or perhaps dark energy will decay into something new, giving birth to another universe entirely. The next chapter in an endless, cosmic cycle. In either case, the same forces that separate galaxies might one day seed their rebirth. You see, the universe is not a machine running down. It's a living process, breathing in and out over unimaginable scales of time. Expansion and contraction, silence and sound, death and renewal, all are part of the same eternal pulse. Dark energy is not a destroyer. It's a reminder that motion never ends, even when everything else does. And here, within that grand motion, is you, a conscious moment made of atoms older than the stars, sustained by sunlight born from fusion, carried by gravity, expanding through time. You are made of the same equations that drive galaxies apart. Your heartbeat and the universe's acceleration are both manifestations of energy-seeking balance. Every inhale you take mirrors the universe's expansion. Every exhale is its rest. So, as you lie in stillness, imagine this truth gently unfolding around you. The space between atoms in your body is widening imperceptibly as dark energy does its quiet work. And yet, within that expansion, your consciousness, your awareness, holds it all together. You are the observer and the observed, the calm in the middle of infinite motion. If this realization feels vast, let it soften you instead of overwhelming you. Because to understand dark energy is to understand serenity, the quiet force that expands the universe, and perhaps the heart itself. Even as the cosmos drifts apart, you remain connected to everything it ever was. 1. Imagine a single atom, the smallest unit of ordinary matter. Now imagine every atom in your body, in the air around you, in the oceans and the mountains and the stars. Each of them has a story, one that began long before Earth existed, in furnaces that burned brighter than 1,000,000 suns. Every atom of carbon in your cells, every drop of oxygen in your lungs, every trace of calcium in your bones, all were born inside stars. When a star runs out of fuel, it collapses. Under immense pressure, its core fuses lighter elements into heavier ones, hydrogen into helium, helium into carbon, carbon into oxygen, and so on. When the star can no longer sustain the fusion, it explodes as a supernova, scattering its contents across space. Those elements drift for millions of years, joining clouds of dust and gas that will one day form new stars and planets. In this cycle of birth, death, and rebirth, the universe forges the raw material of life itself. You are, quite literally, the dust of ancient suns. It's a truth both scientific and poetic. When you touch your hand to your chest and feel your heartbeat, you are feeling the echo of a fusion reaction that took place billions of years ago. When you breathe, you inhale atoms once exhaled by stars that died before our solar system was born. When you look up at the night sky, you are not looking at strangers. You are looking at your origin story. The cosmos is an alchemist. From chaos, it creates chemistry. From heat, it creates harmony. And from death, it creates life. Without supernovae, there would be no carbon for cells, no iron for blood, no phosphorus for DNA. Every living creature is a record of stellar transformation, a collection of ancient light given form. Even the gold that humans have treasured for centuries came from these violent cosmic deaths. When two neutron stars collided, they forged heavy elements in the furnace of their annihilation. That gold traveled through the galaxy for billions of years before becoming part of the planet beneath your feet. Think about that for a moment. The ring on a hand, the wire inside a circuit, the spark that powers a thought, all carry the memory of explosions so vast they shape time itself. What looks solid and familiar is, in truth, the result of endless motion and transformation. Matter never dies. It only changes shape. The universe does not waste a single atom. There's a quiet comfort in that. It means that everything that ever was, every star, every person, every dream, continues in some form. When you exhale, atoms leave your body and drift into the atmosphere, where they might one day be breathed in by someone else, or by the roots of a tree, or even by the sea. In the grand sense, there is no separation. The same particles that make you are already traveling through the rest of existence. This constant exchange is what binds the universe together. It's why astronomers say we are not in the universe, we are of it. You are made of its memory, animated by its energy, and destined to return to its flow. The stars are not above you, they are within you, shining through every moment of awareness. And yet, this knowledge does not make us small. It makes us infinite, because through you, the universe has learned to look back at itself. Every thought, every question, every breath is the cosmos becoming conscious. When you wonder where you came from, it is the stars wondering too. There is poetry hidden in that reflection. That the same atoms forged in distant suns now listen to stories about those very suns. That matter, once blind, has become aware. That the universe, through you, has found a voice that can whisper, I exist. So tonight, as you rest beneath the stars, let this thought settle like stardust in your mind. You are not separate from the cosmos. You are its continuation. Its pulse beats through your veins. Its light breathes through your thoughts. And when your time comes to fade, those atoms will continue their journey, returning to the sky to form new stars, new planets, and perhaps new beings who will one day look up and wonder the same. If that thought gives you peace, let it stay with you like a quiet constellation inside. Because even in silence, you shine. Not borrowed light, but your own, born from the fires of ancient stars. You are the universe, dreaming of itself. 1. Long before there were galaxies, before stars had names or planets had skies, the universe was dark, not empty, just waiting. Out of that darkness, gravity began to draw matter together, shaping the first stars, enormous primitive giants hundreds of times larger than our sun. These were the population 3 stars, the first generation to ever shine, made almost entirely of hydrogen and helium. They burned with an intensity we can scarcely imagine. In just a few million years, a blink in cosmic time, they lived, burned, and died, seeding the universe with the first heavy elements. Those ancient titans lit the cosmos for the very first time. Before them, there was no light, only a sea of gas cooling after the Big Bang. When they ignited, the universe itself changed character. Photons, once trapped in fog, could finally travel freely, illuminating vast clouds of dust and gas. From that moment, the universe began its long transition from darkness to brilliance, a process astronomers call cosmic reionization. It was the dawn of starlight, but the lives of those first stars were brief and furious. Without heavier elements to cool their interiors, they burned fast, fusing hydrogen and helium into heavier nuclei until they collapsed under their own gravity. Some exploded as colossal supernovae, scattering their material across space. Others may have collapsed directly into the first black holes, creating the seeds for the supermassive giants that now sit at the centers of galaxies. Every atom of carbon, oxygen, or iron that exists today began in those fiery deaths. The stars that followed, the ones that gave rise to our sun, inherited their ashes. It is strange to think that the iron flowing through your veins was first forged in a star that lived before the Milky Way even existed. That the oxygen you breathe, the calcium in your bones, and the silicon in your computer all began as cosmic residue from explosions more ancient than imagination. Each new generation of stars carried forward the legacy of the ones before it, enriching the universe with the ingredients for planets and eventually for life. The universe, in a sense, learned how to build complexity, from simple hydrogen to thinking beings who could wonder about hydrogen. Astronomers can't see those first stars directly. They lived too long ago, too far away, but their fingerprints remain. We find them in the faint patterns of light from ancient galaxies, and in the chemical traces preserved in the oldest surviving stars. Through observation and simulation, we reconstruct their stories. How they flared, died, and left behind everything that would one day become us. Even now, telescopes like the James Webb Space Telescope are searching for their echoes, peering back more than 13 billion years, hoping to catch the faintest glimmer from that first generation of light. The idea that something so fleeting could have left such a permanent mark is humbling. It reminds us that even the briefest existence can shape everything that follows. The first stars didn't last long, but without them, there would be no galaxies, no planets, no life, and no eyes to see the night sky they created. Their brilliance was not just light, it was inheritance. In the same way, our own lives are short compared to cosmic time, but they too leave ripples. Every kindness, every discovery, every act of imagination carries forward, changing what comes after. Like starlight crossing the void, the effects of what we do continue long after we're gone. And just as we live from the ashes of ancient suns, future generations will live from the echoes of our light. So tonight, as you drift in thought, imagine those first stars flaring into existence. Vast, silent, and unaware of their legacy, they burned so fiercely that their lives became the foundation for everything that followed. Their light is still traveling through the darkness, still unfolding across time. Perhaps, in some small way, so is yours. If this vision stirs something within you, let it stay. Because like the first stars, you are here for a brief moment. But that moment is enough to fill the dark with light. The first stars died long ago, but their light is still becoming you. When we gaze across the night sky, the Milky Way seems endless, a river of stars stretching beyond imagination. But even this magnificent spiral is only one of an estimated 2 trillion galaxies in the observable universe. Each of those galaxies contains billions, sometimes trillions of stars, countless worlds orbiting in silence. And yet, when astronomers look at the numbers, they find that everything we can see, all the stars, planets, and nebulae, makes up less than 5% of what exists. The rest is hidden in shadow, dark matter and dark energy, invisible forces that shape everything while remaining forever unseen. This unseen structure forms a cosmic web, stretching across billions of light years. Galaxies gather along its filaments like dew on a spider's silk, connected by gravity and separated by vast voids of almost perfect emptiness. The pattern is astonishing. A network of light woven through the dark, mirroring the neural pathways of the human brain. When computer simulations map this structure, the resemblance is unmistakable. The universe itself seems to think in patterns. At the heart of this cosmic web, galaxies live and evolve like living organisms. They are born in clouds of gas, mature through collisions and mergers, and die when their fuel is spent. Our own Milky Way is part of a local group, a small cluster of about 50 galaxies held together by gravity. And beyond that cluster lies a supercluster, then another, and another, until the structure fades into something that defies words. In this grand architecture, every star, every world, every atom is a thread. It's strange to realize that galaxies themselves can be fragile. Over billions of years, gravity pulls them into encounters with their neighbors. Some merge, forming massive ellipticals. Others are torn apart, leaving behind tidal tails of stars stretching for hundreds of thousands of light years. Even the Milky Way's graceful spiral arms are only temporary, waves of density moving through clouds of stars like ripples on water. The galaxies we see today are snapshots, fleeting forms in an ever-changing dance. And yet, there is harmony in that chaos. Each collision triggers bursts of star formation, igniting newborn suns from the ashes of destruction. Even when galaxies tear each other apart, they also give rise to new generations of light. In this way, the universe behaves almost like a forest, old growth collapsing, feeding the soil for what comes next. Creation and dissolution are not opposites. They are partners in the same infinite cycle. From Earth, we see only a small portion of this cosmic forest. But through telescopes like Hubble and James Webb, astronomers can peer across time, capturing galaxies as they were billions of years ago. Some appear as tiny smudges of light, primitive and chaotic, the first structures ever formed. Others, closer and older, display intricate spirals and glowing arms. By arranging these observations, scientists can piece together the universe's autobiography, from a glowing cloud of hydrogen to the tapestry of galaxies we see today. And perhaps the most humbling truth of all is this: galaxies are not permanent. They too will fade. Stars will burn out, leaving behind white dwarfs, neutron stars, and black holes. Gas will run thin, new star formation will cease, and even the grandest galaxies will go dark. Over trillions of years, gravity will pull their remnants into the black holes at their centers. Eventually, only the faint radiation of dying light will remain. A quiet universe, slowly cooling into memory. But before that silence comes, there is this: the age of radiance. The age when galaxies still shine, when light still travels freely across space, when consciousness can look upward and see beauty. This is the universe at its brightest, and you are here for it. A witness to its glow, a part of its unfolding story. So when you look at the Milky Way, don't just see stars. See history, motion, structure, and connection. See yourself reflected in that cosmic web. For just as galaxies cluster and merge, so do human lives, drawn together by unseen gravity, forming constellations of meaning. The same laws that govern galaxies guide us too. We drift, we collide, we change, and somehow in the chaos, we create light. If this thought fills you with wonder, let it stay with you. Because even when galaxies fade, the memory of their light, and of ours, will continue, rippling quietly through the dark. You are living in the universe's moment of brilliance. In the silent reaches of space, between stars and galaxies, lie immense clouds of gas and dust, the raw material from which everything is born. They stretch across light years, delicate and invisible, yet powerful enough to shape entire worlds. These are nebulae, the nurseries of the universe. They are where stars come into being, where light is rekindled from the ashes of what came before. A nebula begins as a cold cloud of hydrogen, floating quietly in darkness. Then something disturbs it. A nearby supernova explosion. A shockwave of gravity, or the slow pull of matter gathering over millions of years. The cloud begins to collapse under its own weight, spinning faster as it shrinks, flattening into a disk. At its center, the pressure rises until hydrogen fuses into helium, and a new star is born. The darkness gives way to brilliance, a single spark that will shine for billions of years. Every star you see in the night sky began this way. Our sun was once a spark in such a cloud, surrounded by a swirling disk of dust and ice that eventually formed the planets. The Earth itself, every rock, every ocean, every living thing, traces its roots back to a nebula that no longer exists. It's a poetic irony. The place that gave us birth is gone, and yet it lives on through everything it created. But nebulae are not only cradles of creation, they are also tombs. When a star dies, it returns its material to space, enriching it with new elements. Massive stars end their lives in supernova explosions, scattering their remains across the galaxy. Smaller stars like our sun will one day shed their outer layers gently, creating glowing shells of color called planetary nebulae. The core that remains becomes a white dwarf, fading slowly into darkness. Even in death, a star gives back to the cosmos, ensuring that new generations can rise. When you see images of the Orion Nebula, the Eagle Nebula, or the Pillars of Creation, You are looking at this endless cycle of birth and renewal. Within those clouds, thousands of young stars are forming right now, each surrounded by disks that may one day become planetary systems. Somewhere within them, future suns are awakening, and perhaps far into the future, another form of life will look up at their sky and wonder where it came from, just as we do. Nebulae are not silent, though they seem so from afar. They hum with radiation, shimmer with ultraviolet light, and ripple with winds from newborn stars. Their gases glow in hues of red and blue and green, each color the fingerprint of a different element: hydrogen, oxygen, sulfur. Through these colors, astronomers can read the composition of the universe like music written in light. The beauty of a nebula lies not only in its color but in its patience. It takes millions of years for a single cloud to give birth to a star. And yet, it never hurries. It simply follows the rhythm of gravity and time. Creation, it seems, prefers stillness. When we look at photographs captured by the Hubble Space Telescope, we often forget how vast these places truly are. One wisp of cloud in the image could be larger than our entire solar system. A single pillar might stretch for dozens of light years, and within them, countless seeds of stars are quietly waiting for the moment they ignite. It's like standing before a cosmic forest, each tree glowing faintly with the promise of light. The connection between these nebulae and our own existence is more than symbolic. The carbon in your body, the oxygen in your breath, the calcium in your bones, all of it once drifted through such a cloud. The atoms that make you were forged in old stars, scattered by their explosions, and gathered again by gravity into new worlds. To exist is to be recycled starlight, to be part of the endless conversation between death and creation. And when the sun reaches the end of its long life billions of years from now, it too will shed its outer layers and become a nebula, glowing gently for a time before fading away. Somewhere in that future, those elements may come together again, perhaps to form new worlds, new oceans, new beings who will look up and marvel at the same cosmic dance. So as you close your eyes tonight, imagine yourself drifting inside one of these clouds, surrounded by colors that human eyes cannot fully see, wrapped in the soft hum of creation. There is no rush here, no beginning or end, only transformation. Every breath, every heartbeat, every moment of quiet reflection is part of the same ancient rhythm that builds the stars. If this thought brings stillness, let it stay with you, because the same forces that shape the galaxies are shaping you too. Quietly, patiently, beautifully. You were born from the calm inside a nebula, and you still carry that calm within you. 1. Not all stars are eternal. Some fade quietly. Others die with fury so intense it reshapes everything around them. These spectacular deaths are called supernovae, the universe's most powerful fireworks, the final breath of massive stars. For a few shining weeks, a single supernova can outshine an entire galaxy, releasing more energy in that brief moment than the sun will emit in its entire lifetime. A supernova begins when a massive star exhausts the nuclear fuel that keeps it stable. Without the outward pressure of fusion to counteract gravity, the core collapses inward. Protons and electrons fuse into neutrons, releasing a blast of energy so vast that the outer layers of the star are hurled into space at tens of thousands of kilometers per second. In that instant, new elements are forged: gold, silver, platinum, uranium, metals that would never exist without such destruction. Every precious stone, every ring, every circuit of technology carries the signature of a star's final breath. If you've ever held something made of gold, you've held the ashes of an ancient sun. Those atoms were born in the heart of a dying star, scattered across the galaxy, gathered into the dust that became Earth, and eventually found their way into your hands. It is an unbroken story, one of fire, loss, and renewal. The universe never wastes its endings. It recycles them into beginnings. There are different kinds of supernovae. Some occur when massive stars collapse under their own gravity, core collapse supernovae. Others, called Type Ia supernovae, happen in binary systems where a white dwarf steals material from its companion star until it grows too heavy and detonates. Each type leaves behind different clues, different elements, different shapes in the cosmic dust. Astronomers use these explosions as markers of distance, measuring how bright they appear to calculate how far away they are. In doing so, they discovered one of the greatest mysteries in cosmology, that the universe is expanding faster than expected, driven by the mysterious force we now call dark energy. So in a way, even the deaths of stars help us measure the life of the cosmos. Each explosion is a clock, a lighthouse, and a teacher, illuminating both the past and the future. When the light from a supernova reaches us, it carries with it a story that began millions of years ago. By the time it touches your eyes, the star that made it is long gone, but its message still arrives. I existed. I burned. I became. Sometimes galaxies collide, triggering chains of supernovae that light up the heavens like a cosmic storm. These bursts seed the surrounding space with the ingredients for new stars and planets. From the ruins of one world, countless others are born. It's the universe's way of renewing itself, one explosion at a time. Yet, not all supernovae are explosions of destruction. They are also acts of creation, of chemistry, of balance, of story. In their blinding light, they remind us that impermanence is not tragedy. It is transformation. Just as stars must die for planets to exist, so too must moments end for new ones to begin. Even the quietest parts of life mirror this cosmic rhythm. A flower blooms, fades, and returns to the soil. And from that soil, new life emerges. A day ends, only for another to rise. The universe follows the same truth, written not in petals, but in stars. If you could stand near a supernova, though no living thing could survive it, the sight would be beyond comprehension. The light would be 1 billion times brighter than daylight. The blast would expand at a fraction of the speed of light, tearing apart nearby worlds, shaping new nebulae, and filling the void with color and dust. And in time, the fire would cool, the light would fade, and silence would return. But that silence would not be empty. It would be full of potential, full of atoms waiting to begin again. So tonight, as you rest, think of that somewhere, even now, a star is ending its life so that others may begin. Its light will travel for millions of years before reaching us. And perhaps one night, far in the future, someone will look up and see it. A single bright flare in the darkness, unaware that its story began long before their own. If this thought humbles you, let it comfort you too, because everything that ends, even you, even me, becomes something new in the endless rhythm of the universe. From destruction comes creation, and from creation, the promise of light again. 1. Every galaxy, every star, every atom we know was once compressed into a single, impossibly small point, a seed of infinite density and energy, the beginning of everything. And then, in a moment that still defies comprehension, it expanded, not into space, but as space itself. That moment is what we call the Big Bang. And it was not an explosion in the usual sense, but the birth of time, space, and matter all at once. There was no before, because there was no time yet. There was no outside, because there was no space beyond it. Everything that would ever exist, every galaxy, every particle, every heartbeat, began in that singular, luminous instant. The universe in its infancy was pure energy. It expanded faster than light, cooled rapidly, and began to transform. energy condensing into particles, particles forming atoms, and atoms giving rise to the first elements: hydrogen, helium, and trace amounts of lithium, the simplest building blocks of all that would follow. In those first few minutes, the universe wrote the basic language of matter. It was a time of unimaginable density and heat, over 1 billion degrees, where photons and particles collided endlessly. Then, as it cooled, structure began to emerge. Gravity pulled matter together, forming the first clouds, the first stars, the first galaxies. From that fire came order, from chaos, harmony. For nearly 14 billion years, the universe has continued to expand. And here we are, small creatures on a tiny planet, capable of looking back and tracing that expansion to its first spark. When you observe the night sky, you are looking across time itself, seeing the faint afterglow of creation still echoing in the form of cosmic microwave background radiation. That glow is everywhere, filling every corner of space with the memory of its birth. If your eyes could see microwaves, the sky would not be black, but softly illuminated with the light of the universe's infancy. The Big Bang wasn't just the start of everything. It was the beginning of change and eternal unfolding. The galaxies continue to drift apart, their light red-shifted by the expansion of space. Over time, the universe will grow colder, darker, and quieter. But that quiet doesn't mean emptiness. It means evolution. The universe is not dying. It is transforming. Perhaps in the far future, it will collapse inward again, giving rise to another Big Bang. A new universe born from the ashes of the old. Or perhaps it will expand forever, stretching time into infinity. In either case, creation is not a single event. It is a rhythm, a breath, an eternal motion. There's a poetic irony in all of this. The same laws that govern the birth of stars also govern the movement of your blood, the firing of neurons, the beat of your heart. You are not separate from the universe's beginning. You are its continuation. The same particles that burst from the Big Bang still move within you. The atoms in your body are ancient, some forged in the first stars, others formed moments after time began. You are, in every sense, a child of that first light. When scientists recreate the early universe inside particle accelerators, smashing atoms together at near light speeds, they catch fleeting glimpses of what it must have been like. Tiny bursts of creation lasting mere fractions of a second. In those moments, we see not chaos, but order hidden within. The universe has always been balanced between destruction and design. Even at its most violent, it was composing something beautiful, a structure that would one day give rise to galaxies, to worlds, to consciousness. It's humbling to realize that the Big Bang still echoes within us. Every second, as atoms vibrate and cells divide, the same energy that began everything continues its quiet work. We are living fragments of the first moment, still expanding, still unfolding, still remembering. So when you look at the stars, remember, you are not looking into the distance. You are looking into the past, into your own origins, into the very event that made seeing possible. The light from the galaxies is not separate from you. It is your ancestor, your reflection. And when you close your eyes, the darkness behind them is not emptiness. It's the space between moments of creation. If this thought brings stillness, let it fill you with gratitude, because every breath, every heartbeat, every spark of thought is a continuation of that first explosion. The Big Bang echoing quietly through your existence. You are not just in the universe, you are the universe, still expanding. 1. Far beyond the boundaries of our solar system, where sunlight fades into cold emptiness, lies an invisible frontier called the interstellar medium. A vast ocean of gas, dust, and magnetic fields connecting everything in the galaxy. It's here that the cosmic web reveals itself. A network of filaments and voids stretching across billions of light years. To the naked eye, it seems like nothingness. Yet this silent structure is the skeleton of the universe, guiding galaxies, shaping stars, and carrying the memory of creation itself. When astronomers map the universe in 3 dimensions, they don't see scattered dots. They see patterns, immense filaments of galaxies woven together by gravity, forming what looks like a colossal web. Between these filaments lie enormous empty spaces called cosmic voids, where galaxies are rare and matter is thin. It's a breathtaking design, the universe as a living network, breathing and expanding with matter flowing along invisible threads like water through veins. Every galaxy, including our Milky Way, is just one bright node in this infinite tapestry. The cosmic web wasn't drawn by hand, but by physics. After the Big Bang, tiny fluctuations in density, mere ripples in the primordial plasma, grew under gravity's pull. Over billions of years, they became filaments of dark matter, pulling gas and dust along with them. Where filaments crossed, galaxies and clusters formed. The dark matter itself is invisible, but its influence can be seen in the dance of galaxies, the bending of light, the very shape of the universe. It's a structure we can't touch, but one we can feel through the rhythm of the cosmos. Some of these filaments stretch for hundreds of millions of light years, connecting galaxies separated by unimaginable distances. They are rivers of matter and energy, flowing slowly across time. And even though we cannot see them directly, their gravitational echo reaches us. When light from distant galaxies passes through them, it bends slightly, an effect called gravitational lensing, allowing astronomers to trace the outline of this invisible architecture. The result is astonishing, an image of the universe not as empty space, but as a glowing web of connection. What's remarkable is how similar this structure is to patterns we see elsewhere. Microscopic neural networks in the human brain, the branching of trees, the pathways of lightning, all echo the same geometry. It's as if the universe builds itself using a single aesthetic, repeating the same design from the smallest scale to the largest. You are made of that same pattern. The electrical circuits in your mind mirror the same symmetry that holds galaxies together. You think, you dream, you wonder, because the cosmos learned to do so through you. Even the silence between galaxies is not empty. It hums faintly with background radiation, relics of early starlight and cosmic rays. Through this space, particles travel endlessly, some created before Earth even existed, crossing billions of light years only to dissolve into another form. This quiet flow of energy binds all things, a whisper of motion too subtle for human senses, but constant and eternal. Sometimes astronomers capture radio waves coming from these vast regions, faint signals that might have begun their journey when dinosaurs walked the Earth. Each wave carries a record of what the universe once was. When it reaches us, it brings a message from the past, a reminder that even across incomprehensible distances, communication never ceases. In that sense, the cosmos is never truly silent. It's always speaking, just in frequencies our hearts must learn to hear. To imagine this web is to imagine the universe breathing, galaxies expanding outward like exhalations, filaments tightening like muscle fibers, dark matter threading everything together in perfect equilibrium. It is not chaos, it is choreography. Every burst of light, every drift of dust, every gravitational pull is a step in an endless cosmic dance. And you, right now, are a part of that rhythm, sitting inside one of its tiny filaments, your atoms humming with the same energy that flows between stars. The next time you look up at the night sky, think of it not as a flat ceiling of stars, but as a deep, connected ocean. Each point of light is not alone. It is tethered to countless others by invisible strings of gravity and time. The space between them is not nothingness, but structure. Even emptiness has architecture. In that realization, there's comfort. It means that nothing in the universe is truly isolated. Not a single star, not a drifting planet, not even you. You are connected to everything, to ancient supernovae, to galaxies you'll never see, to atoms that once belonged to other worlds. The thread of existence runs through all of it, unbroken, luminous, alive. If you ever feel small, remember this. You are woven into the fabric of the cosmos itself, a single vibration in the universal web. And even in silence, the universe feels your presence as part of its song of light and gravity. You are not outside of the cosmic web. You are one of its living threads, glowing softly, holding your place in the story of the stars. Beyond the clusters of galaxies and the delicate threads of the cosmic web, there exists something even grander, a mystery that defines the ultimate fate of everything: dark energy. It is the most dominant force in the universe, yet we do not know what it truly is. It does not emit light, does not pull like gravity, and cannot be touched or seen. But it pushes. It drives galaxies apart faster and faster, stretching the very fabric of space. Because of it, the universe is expanding not at a steady pace, but at an accelerating one. Astronomers first discovered this in the late 1990s, when they measured the brightness of distant supernovae, stellar explosions that act like cosmic mile markers. To their surprise, those supernovae appeared dimmer than expected. That meant they were farther away than they should have been. Something unseen was pushing them, stretching space itself. That something was later named dark energy, and it accounts for nearly 70% of all energy in the universe. Everything we can see, stars, galaxies, planets, even light, makes up less than 5%. The rest is dark matter and dark energy. Invisible, silent, but overwhelmingly powerful. No one knows what dark energy truly is. Some think it's an intrinsic property of space, a constant energy that fills every cubic meter of the cosmos. Others suspect it's something dynamic, a field that changes over time. If it grows stronger, it could one day tear apart galaxies, atoms, and even space-time itself, a scenario known as the Big Rip. If it weakens, gravity might eventually pull everything back together in a final collapse. The Big Crunch. Either way, the destiny of the cosmos lies in its invisible hands. Imagine that. The universe itself has a pulse, a rhythm between expansion and collapse. And we are living right in the middle of its breath, during an era when galaxies still shine and light still travels freely through space. In the distant future, that will no longer be true. The stars will burn out. The galaxies will drift so far apart that their light will never reach each other again. The night sky will grow darker until even the nearest galaxies vanish beyond the cosmic horizon. It will be a universe of silence and isolation, a sea of fading embers. Yet, even that vision holds beauty. It means that everything we experience now, every sunrise, every star, every connection, is happening in a golden age of light, a brief, bright chapter in the universe's vast history. We exist in a moment when the cosmos is visible, knowable, radiant. Our telescopes catch photons that have traveled billions of years to reach us. Messages from galaxies that may already be gone. We are witnessing the universe in bloom before its petals drift into infinity. Dark energy may be unknowable for now, but it also teaches us something profound about humility. It reminds us that our understanding, vast as it seems, still floats on a sea of mystery. The universe is not obliged to be simple or comforting. It is honest. And in its honesty, there is wonder. Because the more we discover, the more we realize how much remains unseen, how much is still waiting beyond the reach of our instruments and our imagination. Scientists continue to chase the shadow of dark energy. They map galaxies, measure cosmic microwave background ripples. and track the slow drift of clusters over billions of years. Each observation adds one more note to the symphony of understanding. We may not yet hear the full melody, but we are learning its rhythm. Every equation, every data point, is a whisper from the cosmos saying, "Keep going." Some believe that dark energy is the natural evolution of the universe's will, its tendency toward expansion, creation, and transformation. Just as a seed must burst open to grow, the cosmos too must stretch to discover what it can become. If that's true, then this endless expansion is not tragedy. It is growth. It's the universe expressing itself, testing its boundaries, reaching for its own horizon. And in that grand story, we are not bystanders. We are participants. Small, yes, but conscious. The universe cannot know itself without observers, without beings who can wonder, measure, and love. Every moment of curiosity, every act of creation, is a mirror held up to the cosmos. Through us, it sees itself, just as through the stars, it shines upon itself. So tonight, as you rest beneath the quiet breath of space, think of this. Every atom in your body is expanding too, carried gently by the same invisible force that moves galaxies. You are growing with the universe, not separate from it, but within it. Every breath you take is in rhythm with the widening of the cosmos. Every heartbeat echoes its slow, unstoppable pulse. If that thought feels too vast, let it soothe you, because you don't need to understand the whole universe to belong to it. You already do. In the stillness of the night, the galaxies drift farther apart, but connection remains. Not through distance, but through awareness. And awareness is the light that dark energy can never extinguish. 1. There is a truth in the night sky whispers if you listen long enough. The universe is not static, and neither are we. Every second, galaxies drift farther apart, stars are born and die, and time itself stretches onward into infinity. And yet, amid this constant motion, there is a quiet harmony, an equilibrium between chaos and creation, light and darkness, existence and absence. If you could see the universe not in space but in time, it would look like a vast symphony frozen in motion. Each note, a supernova, a quasar, a heartbeat, plays its part in an unending melody. And like all great music, it is not the silence between notes that matters least, but most. Because without silence, there would be no rhythm, no awareness, no moment to feel what has been played. That silence, the stillness between galaxies, is the universe's breath, the pause before the next act of creation. Astronomers call this period, we live in the era of stars, a time when light still fills the sky, when fusion still burns in countless suns, when gravity and energy still sculpt the shape of galaxies. But this era, vast as it seems, will one day end. Stars will run out of fuel and fade into darkness. The brilliant spirals of galaxies will dim, leaving only black holes, neutron stars, and cold remnants drifting in the void. And yet, that too will be beautiful, because even endings are part of the cosmic cycle. Black holes, often seen as symbols of finality, may actually be beginnings. Some theories suggest that when they reach their final stages of evaporation, the energy they release could seed new universes, small bursts of creation that continue the cosmic story. If that's true, then nothing ever truly disappears. It simply transforms, evolves, expands into new possibility. The universe, like a tree shedding seeds, is designed for continuation. Even as it decays, it dreams forward. When you look up at the stars tonight, you are seeing this balance play out. Some of the light reaching you has traveled for billions of years. Light from stars that may no longer exist, yet their radiance endures. It's a cosmic illusion, but also a kind of truth. Because in the universe, nothing is wasted. Even vanished stars leave imprints on space-time, echoes in gravitational waves, and dust that becomes the foundation for new worlds. Everything gives way to something else. Our very existence is a testament to that continuity. The carbon in your blood, the calcium in your bones, the iron in your cells, all of it was forged inside stars that lived and died long before the sun was born. You are literally built from the debris of the past. And one day, the atoms that make you will scatter again, returning to the cosmic sea to build something new. A planet, a flower, perhaps another being who will look up and wonder as you do now. We are not merely part of the universe. We are its continuation, the consciousness it has temporarily given itself to witness its own unfolding. It's easy to feel small when thinking about the immensity of the cosmos, but smallness is not insignificance. A single photon can travel across the entire universe. A single thought can reach beyond time, shaping stories, inspiring generations, altering the trajectory of minds yet unborn. You too are made of that same light. What you feel, what you imagine, what you create, these are not separate from the universe's expansion. They are its expansion. Through your awareness, the cosmos learns to reflect on itself. Scientists often say that the universe will one day end in cold darkness, a slow fade into silence where entropy rules and all motion stops. But perhaps that silence is not death, but renewal. Perhaps when everything slows to stillness, it will be the universe's way of inhaling, preparing for another Big Bang, another burst of light and possibility. In that sense, there is no true ending, only transformation. The universe may not repeat itself exactly, but the pattern of creation will always find its way back. And what about us? The brief consciousnesses flickering across its vastness. Perhaps we too are patterns, temporary arrangements of light and thought that dissolve and reform, echoing across dimensions we cannot yet perceive. Perhaps death, like cosmic collapse, is not destruction, but return. The same energy that animates you today will fuel the stars of tomorrow. The same awareness that wonders about infinity will one day awaken in new eyes, on new worlds. Because nothing truly disappears. It only changes form, waiting to shine again. So as the galaxies drift apart and time continues its infinite rhythm, let your thoughts expand too. Let your fears dissolve into perspective. You are not an accident of dust and chance. You are a deliberate moment in the universe's own reflection. When you breathe, the cosmos breathes. When you close your eyes, the stars still burn within you. When you dream, you continue the story of everything. If you ever doubt your place in this vastness, remember this. You are the proof that the universe is aware, because it takes form through you. Your existence is its miracle. Temporary, luminous, and utterly irreplaceable. So rest, not in the fear of ending, but in the certainty of continuation. The universe is not over yet, and neither are you. 1. That's the true immortality of consciousness, not the survival of oneself, but the continuation of awareness itself across ages and forms. Each observer is a spark in an infinite chain of awakening. So tonight, let your mind drift with that thought. You are not here by accident. You are the latest verse in a song that began before time, and though the melody may fade, its resonance will continue in new harmonies beyond your knowing. The stars will carry your atoms. The wind will carry your warmth. The universe will carry your presence, because nothing that has ever existed is ever truly gone. The cosmos does not forget. It stores every vibration, every motion, every thought in its endless archive of being. Even your quietest dreams become part of its symphony. That's why when you listen to the sound of your own breathing in the stillness of night, it feels sacred, because it is the sound of creation, slow to the tempo of a heartbeat. So close your eyes now. Feel the ancient starlight resting on your skin. Let the noise of the day drift away like dust in the solar wind. There's no need to reach or strive. You are already complete, already home, already part of everything. The same space that holds galaxies holds you, too. The same silence that spans billions of light years surrounds you like a lullaby. And as you drift towards sleep, remember this: you are not falling away from the world. You are falling deeper into it, into its rhythm, its mystery, its unending breath. The stars are still burning, the galaxies are still moving. And somewhere in that great cosmic pulse, your heart is beating in perfect synchrony. You are the universe dreaming itself awake. You always have been. You always will be. Good night, traveler among the stars. May your rest be as infinite as the cosmos that cradles you. May your dreams remind you of what you've always known, that you were never alone in the dark. The cosmos is listening, and it remembers you. Good night, and see you in the next video.